Yeah.
Ocean startup project, sea methanol startup. That's a great idea. Where are you located? Newfoundland?
Yeah, sure. Just a moment. Yeah. Um, my name is Abdullah, and I'm from Memorial University of Newfoundland, Canada.
Perfect.
So I'm in St. John's, and
Sure.
I'm a student. I'm second year student in master's program, thesis based, and I'm currently working on photocatalytic conversion of CO2 to methanol. And this is where the startup idea came up from. So converting this dissolved CO2 in seawater into methanol and using the methanol as a feedstock and also as fuel for cars and also for fuels for vessels or ships.
Super.
And yeah, that's all. How about you, Dr. Arif?
Well, I'm in Calgary, Alberta, and I spend major part of my life in oil and gas.
Oh,
Last 7 years, I joined Innotech and I take the role of being a manager for CO2 capture, conversion, and
wow.
utilization. In my current role, I am managing two facilities. One is Alberta Carbon Conversion Technology Center,
Wow.
which today I am here, is a
Okay.
large-scale demonstration facility for de-risking of technology, taking it from lab scale all the way to commercial.
Wow.
And another facility is our research lab, which is just across the street from University of Calgary.
Yeah.
And over there, practically, uh, we do work on a smaller scale uh, technologies and help with
Mm.
the lab scale piloting. So definitely, we will be more than happy to support and help you in any form or shape we can.
Yeah. So just just curious to know, like, on which process are you actually working, like on the capturing process? So which process you utilize for capturing?
So we do have one CO2 capture plant, is a 6 ton per day, is a
Yeah.
amine base.
Okay.
As a result, majority of the technology we work is around the amine based processes. We have developed our own new technology called the amine intensification process.
Yeah.
And we are building the pilot plant, and by August, our new process is going to be operational here at site. But we do have a solid adsorbent as well. We have developed a solid absorbent, which possibly that's going to be useful
Yeah.
for you
Yeah.
because the solid absorbent we developed was designed to capture CO2 directly from exhaust gas.
Oh.
And it was intended to be used for marine vessels.
Yeah.
Because marine vessels, they don't like solvent, they don't like big plant. As a
Yeah.
result, we develop a solid absorbent which can
Right.
capture CO2 at 600 degrees C and
Yeah.
release it at 750 degrees C
Wow.
because a combination of that solid absorbent for CO2 capture and your conversion process that can be ideal for marine vessels, cruise ship, and those
Yeah.
type of operation. Because there another challenge is okay, now we capture the CO2, what we gonna do with the CO2?
Yes.
Definitely, that's one technology that it can be attached to the front end of your
Right.
process.
Yeah.
We capture the CO2 directly from exhaust gas
Hmm.
and practically convert it to methanol.
Yeah, that's great. And so last question before we move on, like which technology you use for converting it into methanol or something?
So we are government organization. We don't
Okay.
go to the final thing and go to the market sell. All what we do,
Right.
we develop the technology, we license it to people
Yeah.
like yourself to go and to the market.
Mhm.
In a conversion area, one area that we were successful, we developed the catalyst for dry methane reforming.
Okay. Yeah.
So practically, we convert CO2 to the syngas.
Yeah.
The rest is up to company what they want to produce from syngas. Right now, we have
Mm.
two company. They license the catalyst. One They are focusing on DME production. Another one they want to convert to graphite. So we don't dictate the final product. We gave them the catalyst to convert to the syngas to whatever they want. That's their
Right.
decision.
Yeah, that's the one advantage where you can tweak according to your target product required with the catalyst. So that's one good news, and I'm very much intrigued by your expertise in the field which you are working on, and also your contribution. I really appreciate that. And
Excellent.
let me I think I will just share the presentation for like very short time so that it gives a wider view and moving on.
So Abdullah, do you have already established company? Or-
No, actually, I have not established any company. I'm still a master's student, so it was just so this idea challenge was a step ahead to validate the idea which I proposed. So
Okay,
whether it's something which you can commercialize in the future, or you can work on it, or you can just abandon the idea. That's the main result of being in this challenge. So it's just for 2 months. Um, and yeah, so it's just for 2 months and only to validate the idea
sure.
or in order to understand. So yes, if you can work on this project, what are the ideas you need to refine. So I take these interviews in order to get the feedback and to refine my and to tweak my process, or to understand it in a much better way. um yeah, so moving on, I think, and just a quick slide one because I already got an overview. Yeah. So is my screen visible, doctor?
It's coming. Okay, now I see it.
Yeah. So as we know that the decarbonization challenge and coming on to the process. So this is the main process where we want to work on. And I have also worked on, so this red line show that I have worked on the photocatalytic conversion. So this is the lab scale work which I am doing in my lab. So I designed the photocatalyst, and this photocatalyst is used for conversion of CO2 to methanol. And as we know that it's a water splitting reaction, and which gets add up with the which reacts with the CO2 six hydrogen electrons required for the conversion of the methanol. So the main role is being played by the photocatalyst, so which is more likely a heterojunction photocatalyst, which is formed from two materials, and both of them are one of them is more photo incident, so photoactive than the other, because we need to look on the recombination problem. So in order to address that problem, we needed to form the heterojunction. And our target product is methanol, but it produce some of the byproducts such as formic acid, and also in gas it produced like methane, but those were very small amount as compared to methanol. As we synthesize this catalyst to target methanol production, and and I and we also received an excellent methanol yield, and also with excellent activity and stability with no leaching of the metal content, and they are easy to synthesize. So this is the mechanism, this is the prospective mechanism, and I'm still working on developing the mechanism, and this is very lab scale level. And so I tried to find the liquid product mechanism for now, and the gas product mechanism still working on it due to some challenges in getting those calibration cylinders and all those, because it's very difficult to get some chemicals in St. John's, and a long time takes a lot of time. And the idea is to use the product to sell the product methanol. That's where we generate the revenue. So you have the green methanol as the product, and also the green hydrogen. But this is green hydrogen part is something which we look in the very future. This is something which you look in the near future. And in that case, it would be like a dual revenue, as we know that it's very difficult to store hydrogen than compared to methanol, because hydrogen is gas and methanol is a liquid fuel. So it becomes easy to store it and easy to transport it compared to hydrogen. And the global opportunities and methanol vessels and methanol market and mm, yeah. Yeah, that's all. And these are the advantages of using methanol instead of fossil-based fuels.
So, I mean, one question
Yeah.
for your photocatalytic, are you planning to use the daytime solar light, or it is
Mm,
something that you are going to have install LED and practically artificial light?
Currently, we in the lab we do not we are working on using an artificial light. So we have a UV light producer which produces UV light, and then we use a filter in order to convert that UV light to visible light, so that it concentrates on the reactor more. Because we do not have sunlight here. That's why this project is more on a global level than being targeting it to Canada because of the because
Oh, in Alberta, we have lots of sunlight.
oh, that's great.
Yeah, maybe Alberta is one of the sunshine practical province in Canada. We don't have a problem with sunlight. And that was my question because that is going to affect the LCA and economy of your project.
Right.
The weakness of majority of the photocatalytic processes are
Yeah.
number one, the cost of electricity.
Right.
Number two, where you get your electricity. If it is renewable, you're going to be in good shape. But if you are in Alberta, your electricity is produced by burning natural gas. So
Yeah.
every kilowatt hour has 400 grams CO2 attached into it. And you end up
Mm.
converting less CO2 than what you consume to convert that CO2. And that's going to kill overall your feasibility of your project.
Right.
So exactly as you mentioned, you are in a very right path to more think about global application. Actually, not global.
Yeah.
If you behind you is a picture of the ocean startup project,
Yeah.
that's where you need to focus because majority of the marine transportation happen close to Ecuador area and you get lots of sunlight.
Yeah.
And that's gonna be the best area that you can focus because I talk with majority of the marine transportation company, the biggest dilemma for them is if they capture the CO2, what they're gonna do with the CO2.
Oh,
Uh,
right.
right now, one of the some of the crazy plan is to put them in some sort of bullet, or leave them on the ocean. Somebody else come and collect those bullet, which is crazy idea. Or some people they want to convert them to the rock, then they carry the rock. But if you are able to use the solar energy to convert it to the methanol that they can use as a fuel,
Yeah.
boom, you have the answer for them. Now the deficiency for you is going to be how you capture the CO2, and that's a part that Inotech can complement. Then we license our solid absorbent for capturing the CO2 and your technology converted to the methanol. If you put your story that way, you will have a very robust defendable and marketable idea that you can take to the market. Stay
Yes.
away from using electricity for photocatalysts because
Yeah.
we did work with some photocatalysts. I personally I prefer thermal catalysts because in Alberta natural gas is cheap. I burn
Mm.
the natural gas, I get to any temperature I want, and thermocatalyst catalyst, I have a better control because the parameter I need to control is a heat distribution. In your
Right.
case, is a light penetration.
Right.
So how you design your reactor that you get maximum penetration of the light to your catalyst, which is more challenging compared to the case of heat distribution. Heat distribution is just the brute force of the temperature. Push it is going to go through everything.
Yeah.
I would highly recommend, and you can adopt lots of great idea from algae to oil photoreactors. Those guys they made amazing development on how they design these photoreactor for algae grow. So they are not going with the big fat reactor. They are going with the smaller tubular type of the reactor to
Yeah.
maximize the light penetration
Yeah.
to the reactor. So you can take some model from algae.
Could you
Uh,
please share that in the chat if you're convenient?
sure, let me find the
Yeah.
chat. Uh, where is the chat? Okay, I got it here.
Yeah.
10 years ago, algae to oil was a big initiative, and everybody was working to convert CO2 through algae to the biofuel.
Oh, yeah.
And during that time, there was massive development on design of the photobioreactor that you can
Oh,
adopt the same concept.
yeah.
I do believe you do have a huge potential. Forget about Canada.
Yeah.
You focus on marine transportation application over there.
Yeah.
Let's start as soon as you start your company. Uh, the moment you register, I will help you and connect you to the Alberta Innovate to get some funding, and we can license our solid absorbent to your company. That then you can have direct CO2 capture from exhaust of the ship and
Yeah.
converted to the methanol that they can use as their
Yeah.
fuel. That's an amazing story to tell,
Yeah.
and that will put you in the right path.
Yeah.
Forget about Canada. With Canada, cold climate, dealing with the practically water in this type of photoreactor is challenge. You need to keep it warm. Focus on global application,
Right.
places that they have a high temperature and they have lots of sunlight. Greece, Turkey, UAE, Saudi Arabia, all these
Yeah.
countries, they are after this type of technology. And after you establish your company, I will be more than glad to connect you with some of the companies that we were dealing with,
Yeah.
and that will set you in the right path to start your operation.
Yeah, actually, at this level, I feel that I'm constricted to the lab work, and it's something I cannot scale up because the lab do not have that capacity to do it.
Don't worry, you
Yeah,
don't feel limited. Work with your prof.
yeah,
The Memorial University, they do have a good program to support startup companies.
yeah.
Spin-off. Become
Uh,
a spin-off of
they they do not have the support to startup companies, but this is a part of another ocean startup project. It's something which is from Nova Scotia, so I just register for their program. They do have programs for this. Yeah, they have the lab to market oceans. So I'm planning to actually move on to the lab to market oceans after I complete the Ocean Idea Challenge. And the main reason would be to receive some of the funding to scale up the process. So
and,
currently
and
I
and we can help you with the scale up in our lab here in Calgary. We
yeah,
are fully equipped and we can take the practically from 1 gram type of the catalyst all the way to 400 kilogram catalyst.
all
So
right.
we are well equipped to help you through that process, and feel free to use our name for the capture part of your process.
Yeah,
But I would highly recommend don't wait. This is a market that who is faster to market is going to be winner. Start establish your company. I will try to connect you with Albert Innovate. You can apply for some funding here as well.
yeah,
Start working in that direction and don't think too much.
yeah,
Push.
that's great
Now
to
you are
hear.
in a stage that you need just put your shoulder behind it and push it hard.
Yeah.
And I will be more than glad to support and help you in any form or shape I can.
Thank you very much for your support. It's very kind gesture and warm welcome. I really appreciate that, and that's the point I was looking for because doing something in St. John's is like very difficult and because compared to other provinces,
Absolutely.
and yeah,
This
that's
is my
great.
email address, my work
Yeah.
email address. Feel free to contact through my work email address. And as soon as you establish your company, let's jump on it and let's see how we can help you.
Yeah, sure. That's great. I will. That's the next step which I look forward, and I'll get it. We'll stay in touch, and it was very insightful and something encouraging to do. And I I really appreciate your
No,
idea and
absolutely.
appreciate your feedback and your support. And
No, it is great to see that young generation, young people, they are ambitious and you guys want to have a role and impact and that's our job as a little bit peer or senior people to help you guys
yes,
to find your way for having that impact. I have to jump to another meeting.
yeah,
It
sure,
was
sure.
really pleasure meeting you
Yeah,
and good luck and let's keep in touch.
yeah, sure. Thank you.
Okay, thanks.
Thank you,
Take
Dr.
care.
Arif. Have a nice
Thanks.
day.
You
We'll
too.
stay in
Bye.
touch.